You know, we see these massive trucks on the road every day, and I think we take for granted the incredible engineering that goes into making them safe, especially something as critical as the brakes.
It's true. And the manufacturing of a core component like a brake lining is surprisingly complex. It all starts with really precise grinding and machining.
Right, the production process starts with shaping that inner arc to match specific drum diameters. You're looking at ranges like R140 to R215 for commercial vehicles. Then there's the outer arc to make sure contact and heat dissipation are just right. The edges are also chamfered, often at a 45-degree angle to cut down on noise and wear.
And that chamfering is a perfect example of a small detail with a huge impact. It's not just about smoothing an edge, it's designed to prevent sharp contact points, which is what helps reduce vibration and that awful squealing noise you sometimes hear during braking.
So these initial shaping steps are absolutely critical for performance and safety. But beyond just getting the shape right, what other essential operations are integrated into these automated lines to make a complete and functional brake lining?
Well, after the main shaping, the line moves into other key functions. This is where you get things like automated drilling for the mounting holes.
I see. So these automated lines drill the mounting holes for rivets or bolts, and I read these can also act as ventilation points. They also use these big dust collection systems to capture all the grinding byproducts, which sounds important for safety. And sometimes they add coating, like with an inkjet or laser, for traceability.
Exactly, and that dust collection system is a great point. It's not just about protecting the workers from breathing in hazardous stuff, it's also critical for the quality of the final product. If that dust gets everywhere, it can contaminate the lining or even cause the machinery to malfunction.
That makes sense. So these secondary operations are key to both function and the overall integrity of the part. Bringing it all together then, what are the big picture benefits that make these automated lines so advantageous for manufacturers?
It really boils down to three things: precision, efficiency, and safety.
So the key advantage of these automated lines is their ability to deliver really high precision and consistency. This obviously boosts production efficiency and cuts down on manufacturing costs. Plus, by automating the dangerous tasks, worker safety gets a huge bump, and one operator can manage multiple machines, which is a big deal for optimizing labor.
That's the core of it. This isn't just about making more parts faster. It's about making them consistently better and safer, which is absolutely paramount in the trucking industry, where a single component failure can have catastrophic consequences.
You mentioned that these lines help meet evolving industry demands, especially with EVs and autonomous driving. How does the consistency and precision from these automated lines directly translate into tangible safety improvements or efficiency gains that are specifically relevant to those advanced vehicle technologies?
That's a great point. For EVs, precise brake lining performance is crucial for regenerative braking systems, ensuring seamless integration and optimal energy recovery. For autonomous driving, the unwavering reliability of brakes is non-negotiable. Any variability could be catastrophic. Automated lines provide that baseline consistency, which is the foundation for these complex systems to operate safely and effectively.
Wow, that connection is incredibly important. The fundamental reliability built by automation is what enables these future automotive advancements. It really sounds like a clear win for efficiency, safety, and future readiness.
Absolutely. When you look at the whole process, it's a story of precision manufacturing for truck safety. You start with precise grinding and shaping, add in essential functions like drilling and cleaning, and the result of automating all this is a highly reliable, cost-effective, and safe component. It's a critical investment, especially as vehicles get more advanced,